Alright, let's get started here with hypothesis testing with one sample. So, hypothesis testing is kind of the pinnacle of the inferential statistics. This is what we've been building to. Unfortunately, we won't put it into practice a whole lot. Time just isn't going to allow for that with this course. But I really, really want you to understand why we do it, why it's important, what it means. So let's start here with just going over definitions. So our null hypothesis is the statement about the population that's believed to be true. The alternative hypothesis is what we think might be different from the truth. So basically think of this as, this is going to be an X, this is going to be a mean of a sample, and this is going to be the mean of the sampling distribution of the mean. So this is like, if we take 100 samples, the mean of all those samples is going to be our null hypothesis. And this is going to be one sample that we take on its own. So as an example here, just to kind of put this into terms, so consider COVID. So, the CDC says that recovery time from COVID is 7 days. These numbers are all made up. And the alternative hypothesis, remember this would be an X, it would be a researcher that says recovery time is actually 4 days. So this researcher would have a sample. He's not just making it up. He's just saying that I think from what I've seen, it's actually 4 days. Well, is this different enough than the 7 days that, we can just say, well, yeah, we have a sample here saying 4 days, so 7 days can't be right. We have 100 people there and the average is 4 days, so I don't think it's 7 days. Possibly, we might be able to do that. So what if this instead is 6.5 days? So the CDC says that it takes 7 days to recover, and a researcher is like, no, it's 6.5. Well, can we really say that 7 is wrong? Well, maybe if it's 1 day. If it's 1 day, the researcher says everybody is recovering in 1 day, you're completely fine after 1 day. Well, you'd have to think that, 7 days is incorrect. When can we make that decision to reject it? Well, that's based on our confidence level. It's going to be based on the standard error, the margin of error, and going back to those confidence intervals that we talked about. So the higher the confidence level, 99%, we're going to require this number to be very, very different. This is going to have to be very different than that. But as our confidence level drops, these can be a little bit closer because we don't have to be 100% sure when we're making that rejection. We accept a little bit of error. Now, why is this a useful example, and why do we do hypothesis testings? Well, consider this. Maybe the researcher isn't just a researcher, he's a COVID vaccine researcher. His sample is of people who have received the vaccine. Now he's saying that if you receive the vaccine, your recovery time is 4 days. And the CDC is saying that the recovery time is 7 days. And it assume that, it is in the rejection region. Say it is statistically different from 7 days. It is, it falls outside of our confidence interval. Well, if that confidence interval is like 99%, it's 99%, well, we say that the vaccine causes a decrease in COVID recovery time. So you have to be careful when you say causes, and quite honestly, this is not the right time to use it. I'm just putting it here because it helps make that argument. This is why we do it, because you want to be able to show this, and this is one major step in doing that. Now let's look at it visually. So we've already looked at this, right? We have in our null hypothesis, we're going to assume that the null is 0. And you can do null hypothesis both ways. It's just greater or less than, but we're going to say null hypothesis here, and we could be greater or less than. So, this is our confidence interval at 68% between 1 and 1 standard deviation. Our 95% is between -2 and 2, and our 99% confidence interval is between -3 and 3. Remember, this is drawn from the empirical rule. Another way to visualize it, remember, look at how much area is under here. So right here we have 2.5%, 2.5%, another 2.5%. So when we start thinking about this as, instead of our tails as rejection regions, so if our null HO is here and our H1 is here, we don't reject. It's in the non-rejection region. But if our HO is 7 days here and our A is 4 days, and 4 days is over here, it's more than 3 standard deviations if we're at the 99%. You know, if we're way over here, then we're going to say that it is different. This is how the tests are conducted. And just a little bit more on that, not much more. You know, remember that as your confidence interval goes down, that rejection region gets smaller. So go back here. If instead of 99%, we make it, or say instead of 7 days, we have 6 days, and you know, it's only here. Well, it's not quite different enough. But what if we have a whole lot of variation and our standard deviation is actually, our z-scores are a little different? You know, sorry, I'm getting a little caught up in all this, but basically the rejection area, the rejection region will move and your HA won't. Depending on your rejection region and the confidence level, you may or may not reject a certain alternative or null hypothesis based on the alternative.